We have Professor Surendra P. Shah with us. He is an emeritus professor at Northwestern University. He has been at Northwestern University since the early 1980s. We are also fortunate that he is a distinguished professor at IIT Madras. Thank you for being here and visiting us often and talking to our students and mentoring us. There is a lot that I can say of Professor Shah. I have known him from when I was a student at Northwestern in the 80s. He is one of the top people, and I think, in my opinion, the leader in concrete science and technology for many years. In terms of the impact, if we just look at the papers that he has published, reports that he has written and committees that he has headed, he has close to or more than 1000 publications. Out of that, about 500 or close to 500 would be journal papers. And if you look at citations, I just pulled up some data on Google Scholar. He has 52,000 citations. His H index is much more than 100, and I don't think he will look at statistics, no, but the I-10 index is about more than 1000. So it is very impressive, the impact that he has had on civil engineering, especially the materials research. Now what I would like to ask Suru is, what do you think are the greatest milestones in your career, or what are the biggest things that you have sort of brought up and shown the
first,
future?
Let me tell you that I really enjoyed coming to IIT and talking with students and the faculty, and I am very impressed with the young students you have, and and I think I also appreciate the fact that you have a considering many places, large number of female students, very bright and hardworking. So, and for me, coming here, I learn from you a lot, and that's what keeps me going, learning new things. It's hard, I started, I have been very fortunate right from the beginning that I got interested and got good support in doing my research. When I started as an assistant professor at University of Illinois, I was in the Department of Materials Engineering, and actually I taught undergraduate courses in material science. So I got, although my PhD was civil structural engineering, so I got good flavor of interdisciplinary. And one of the things, for me is that I enjoyed working in new things. Fiber reinforced concrete was one of the first one that I did research on. Then we had organized the first high strength conference, which was NSF funded, and Danyak was the co-chair. Bazan, I was at UIC, and Bazan, Professor Bazan that time at Northwestern. And so that time, high strength concrete was relatively new, and we call high strength concrete as 40 to 50 megapascal, and the development now we are talking about 200 megapascal. So that's, I think that the increase in strength, look at that way, increase in strength has been quite remarkable, and I'm glad I'm part of it. Then I think when I moved from University of Illinois Chicago to Northwestern was certainly very, very important. Northwestern has one of the top-notch research-based university. I was very, very fortunate that excellent students. For example, Professor Gatu, we were just then installing a closed-loop system, and he was keen, so he went to Minneapolis to visit MTH to design our system. So we had, I think that for teaching, the learning and having the student is the most rewarding thing. They become part of your family. So I would say my highlight is having top-notch students, and then it turned out that more or less immediately the Air Force said they wanted a center in concrete. They said, look, without a pavement, we couldn't land our super duper airplane. So they had selected 3, 4, and I put a interdisciplinary team, but we didn't get it. University of Illinois at Urbana got the center. But then the National Science Foundation came up with a big proposal called Science and Technology Center. And so University of Illinois said, look, we have the Air Force Center, so why don't you take a lead? And we applied, and we were very fortunate because it's very competitive. So that center was interdisciplinary, inter-university, and for me, I learned a lot from people in chemical engineering and electrical engineering and certainly material science, because our center was based in science division of NSF. So that was certainly for me, a very important learning experience. I also learned how to be an administrator as a director, which is also very learning experience and a very very useful. And I think that when you decide to retire, as you know, in US you don't have to retire, you can continue. But after a certain time, I thought that I would like to, the day-to-day managing the center was too much, so I did retire. And I've been very, very fortunate that I keep doing and learning new things. I am certainly coming here. I have similar involvement in Hong Kong and China, and that has been nourishing. And so when you people are quite a bit younger, so you may not realize, but it is a challenge what to do when you grow old. You can play bridge if you want to, but I think that I find this very rewarding and satisfying, working with the young people and learning new things.
Well, coming back to a couple of the things that you mentioned, the ACBM Center was really a landmark.
Yes.
And I think in concrete science and engineering research, there is a before and after. And Professor Manu Santhanam and I were fortunate to be students in that center, and we learnt a lot. And it was a center that involved, like you said, large groups, and certainly managerial skills were important to keep the group together. It's not easy to have top researchers from 4 different institutions to work together. And very importantly, and this I would like you to elaborate on, was that you could bring industry also in. So it was not just based on lab work or theory, but you could get industry to participate. And I suppose that was a major influence on the sector.
That's a certainly good point. And I think that industrial involvement and seeing your work put into practice through industry is certainly very important. I know you have been very fortunate here to have a program with Larsen and Turbo. When the center started, National Science Foundation insisted that you have industrial program. And in the beginning we were so busy, so we paid lip service, yes, and we will organize seminar and invite industry. But then NSF insisted that it has to be much more intense, and so we decided to hire an industrial liaison person. And then myself and my co-director, he was from University of Illinois, Francis Young, we went to different industry, presented our work, and they liked the idea that we had this 4 top-notch university plus the government lab, NIST, with us. And one of the industrial partners said this is like one-stop shopping. So they learn new things. They very much like interacting with students, because students, they're good for them to as far as placement. And what we had was that we invite twice a year industrial partners and present what we are doing, and one evening with wine and cheese have student posters, and industry then select which is the best poster and give good like 500 or 1,000, and that worked very well. So I think it certainly for us industrial contact was important as far as knowing that our research eventually may get into the practice. And also important that the research was governed by the basic curiosity and science need, and industry like that because it was primarily funded by NSF, so they can then learn, and if they find something useful then they can have a separate relationship with that faculty, and that worked out well.
And certainly you have a very large network, and I think that is something that we appreciate, those who were at ACBM and were at Northwestern, was that you brought together a lot of people and that network continues. Yes. I suppose you know people in any part of the world. Yeah. I am sure that you will land up anywhere, and certainly there will be 10 people who know you. And what I would also like to highlight is Professor Shah is a fellow of 3 academies, the American, Indian and Chinese, and I believe he is the only engineer who is a fellow of 3 national, only civil engineer who is a member of 3 national academies. And as I said, the network has been very useful in keeping people together, having a dialogue and having information exchange. And this has also been continued in a lot of committees, lot of international organizations. He is a fellow of RILEM and the ACI, and this has also been reflection of the impact that he has had on industry. And another thing that I would like to highlight is that he has had a lot of students, and the students have really enjoyed working with him, and then I also see that you continue to enjoy talking to students and discussing with students, and this I suppose is very important.
Yeah, and I like to point out what you mentioned about the international aspects. I think it's very important that science and engineering we are doing, the issues are the same whether we are in India or China or England, and so and I'm glad that your students are involved in the international aspects. They go to international conferences, and you have organized just last September this RILEM conference, and students said that was very good because they meet people from around the world. Similarly, when we had visitors at the center, and I'm sure you have visitors, so I asked students, and students are keen to volunteer to show them around the lab, because then they get to interact with that industrial or faculty members. So it's very, very useful to have this international connections. And because my former students are at many places, so that also is very rewarding for me to visit them.
And also I think part of the training that you gave your students, you would encourage them to go to conferences while they were students. Yes. And make presentations, because sometimes we see that faculty members want to sort of take up the task of presenting all the work themselves. Yeah. But you very early on and with a large group of students, you made them present, and this I think also helped them get faculty positions and go on.
Oh, absolutely. In fact, my first job, I had gone to present a paper which has to do with my work I was at Cornell in Florida, and this was in January, so Ithaca is very cold. So after my talk, I decided to take advantage of swimming pool, and who else was swimming was Adam Neville. So he said, I heard your talk, very interesting, and are you planning to go to industry or teaching? I said, I'm planning to go on teaching. So Adam went, he was then at Calgary. So he went to Calgary and made me an offer. And as a graduate student, without any interview, first offer. So I was quite excited, but Calgary seemed so far, so I wrote to him that, thank you, but I like to visit. So I visited in February, and that was bad. It was very, very cold, and Calgary that time was not, now it's much, much improved, but that time it was a very conservative place. In the bar, men sit on one side and women on another, and I know Dorothy won't be very happy. But so it certainly presentation for students at international and national conferences is very important. And you present how you present it, and you can learn from what, for example, your professor, how to present your ideas, very important.
Well, talking about presentations, one thing that people appreciate when you talk is you make things sound very simple, very easy to understand. But I'm sure there have been struggles to put forward ideas. I remember that when you started working on high strength concrete at Cornell, and even when this topic of strain softening, I remember being in discussions where the majority of people would say that concrete strain softening is artificial, it is just a machine giving, and it's not a real phenomenon. And now in 30 years, I think you can't even think that a discussion like that would happen.
Yeah, that's a good point. We had, with very, very high strength concrete, if you test in a quality control machine, you have brittle failure. So people say, so then we developed to test with this circumferential control, and you get the strain softening. And people say, well, as Professor Getu said, that's artificial. I mean, that's not real. And in fact, Arthur Nilsson from Cornell, they say, no, he doesn't believe in strain softening. So that's fun.
And there were 80s even books written about the plasticity of concrete. Now, that brings me to this important thing of experimental research. You've always been in the forefront of experimental research to explain and to understand the fundamental behavior and what leads to structures. But we find more and more, and probably that happened to you also, is that people tend to work more on modeling, analytical research, because experiments are difficult, need a lot of patience, you need a lot of resources. But what has kept you going all these years? You've focused on new techniques and experimental work.
No, it's certainly true. This is also true in physics as well, right? If you see one paper in physics with neuron or something, there will be 25 authors, because experiments are very difficult to do. And I think sometimes some civil engineering mindset is to do classical testing. And in order to get more information to characterize material at the fundamental level, you often have to develop innovative techniques. As Professor Getu said, that there's not only closed loop testing where he was involved, and then with the laser holography, we were studying the fracture process zone, and then eventually we were now characterizing material at the nanoscale. And people are realizing more and more that the lot of excitement in material science type of research in civil engineering, and that's of course involves quite a bit of innovative experimentation, careful experimentation, and many classical civil engineering, they don't have the kind of material science approach and facilities that we had at CBM Center, and now you have. So it's very important to have that. And certainly we have to validate our model with our experimental finding and connect it with modeling, so that will make us better understand and generalize the phenomena. So you need certainly both, but because of the importance of advances we made in computation aspect in IT, people tend to do more, sometimes tend towards numerical modeling rather than experiment. But for fundamental breakthrough, you need certainly solid innovative experimental research at different scales, and then modeling.
Well, I suppose you have seen these waves where modeling is sort of takes over.
Yes.
People think that modeling is enough.
Yeah.
At least when we were students at Northwestern, there was a rumor. I don't know if it's true that it was the Northwestern civil engineering and applied mechanics was so strong in analysis that they said that we will not need large testing machines,
Yes.
and they threw away or tried to dismantle
They
a
did.
£1,000,000 machine. And only after you came and then the group was there, that testing picked up.
Northwestern had a £1,000,000 compression or maybe even universal testing machine. But as Professor Getu said, there was a strong group in mechanics, so that nobody was doing it. So they did get rid of it. So when I started, there was absolutely no testing, no experimental facility. So we started with somehow I found an Instron machine and we started with that, and then we built on that, and then of course people realize how important it is to do the experiments and connect it with modeling.
So you continue to believe that experiments are certainly necessary, and along with the required modeling. Well, I also know that other than your focus on research and technology transfer, you also believe that life should be lived well. Yeah. So you travel a lot, you spend a lot of time in fitness and food and
yes, I like
wine.
That's my obsession, food. That's sometimes because when we go to the conferences, my former students know that if we go out to eat with Professor Shah, better have a heavy wallet, because I like to eat good food, and certainly there's abundance of that in China and other parts of the world. So I like food. I like also to cook good food, wine, and travel. Yeah. We have been trying so far successfully to travel together for few days in India, and we went to Bhutan. So that's.
But sometimes as researchers we find that you should focus only on work, and it is not good to do other things. But I suppose you don't believe, or you think that one will also help because you.
Certainly, yeah. I mean, people have different hobbies. Some people have good, music. One of my student, Nathan Traeger, did PhD, but he had a joint minor in music, and he really liked music, and it really helps, later on, whatever hobby you have, it's very important to have that, and you are learning music and
well, to finish,
photography for you.
To finish, what do you think is the future of concrete? Will they be concrete in the next 50 years, or do you so you work so much on materials, new materials? Is there something that will replace concrete in the near future? What do you think?
Yeah, well, people, certainly there are issues, and we can improve the sustainability of concrete. And I mean, you can see that actually we are using more concrete, not less. All super tall buildings are now made with concrete rather than steel. But in highways, bridges and other things, concrete would be there, and many, many applications. So I don't see, and especially in Asia, and also increasingly in Africa, we will need more infrastructure, more urban housing, because UN says that there is a strong shift from in urban housing to be energy efficient, has to be high-rise building, and then the concrete will play a major role. But it doesn't mean that it needs improvement and innovation. It needs alteration, and that's certainly already happening. I mean, when you look at it, when I started, 30 megapascal was the normal, and now we are talking about ready mix can deliver 150. So that's a big improvement. The same thing in many, many other aspects. So it's a, the progress has been remarkable, and I would think that it continues to be remarkable. We need that.
Well, Thank you very much.
my
It's
pleasure.
always a pleasure talking to you and having you visit us. Thank you.
Great. Okay.